So good afternoon, everyone. Welcome back to Math 122. Today we're going to be we're going to finish Chapter 3, actually, today. So we're going to learn the last two rules for derivatives. And then Chapter 4 is going to be all about using derivatives to do all kinds of different things. Okay? So Chapter 2, we kind of learned what is a derivative. Chapter 3, we learn how to do all sorts of different derivatives, and then Chapter 4, we learn how to apply them to various problems. Okay, so that's going to be the route that we're taking. So regarding your homework, you have a homework assignment due on Monday. Today we're going to talk over the last two rules, so you should know everything that you need to know to do that homework assignment. There's also a quiz today, which is over sections 2.5, 3.1, and 3.2. So that does not include chain rule. My office hours are unchanged. Math Tutoring Center, unchanged. SI, unchanged? Unchanged. Okay, great. So any administrative questions before we start in on content for today? One of the homework questions? Sure, which one?
Section 3.1,
Section 3.1, question number 8, and can you read it out for me?
It's find the derivative of 5t to the 10th minus
Sorry, 5t to the 10th minus
12 and then square root t plus 8 over t.
Okay, sure, we can review this one really quickly before we go back to chain rule stuff. Okay, so this is a standard power rule problem. Okay, so the trick that you're going to notice with a lot of these rules is you have to first identify when you need to use a rule. And you can use the rule anytime that your function looks like the rule in question. So for this one, the rule is that t to the n, the derivative of t to the n, oops, not t, x, but t, ddt of t to the n, the power rule says that this will be equal to n times t to the n minus 1, right? Multiply down the old power, make the power one less than it was before. But for this particular example, it only looks like the first thing is going to fit into this rule, okay? But it turns out that the second two functions also fit into this rule in the following way. The first step of this problem is not to go ahead and try to do all of these derivatives, but rather to rewrite this entire thing. I'm going to leave 5t to the 10 alone because it already looks nice. But I'm going to change this one to look like what's in the parentheses here, right? So I can write a square root as a power if I write it as a t to the 1/2. Likewise, with 8 over t, I can rewrite that as 8 times t to the negative 1. Okay, so from here, now I have everything looking just like how it is in the rule. I can go ahead and apply the rule in each case. So the first one I think most people will be comfortable with. It becomes 50 because we multiply 10 times 5, and then t to the 9. Okay, t to the 9. And then minus, and then what happens? We multiply 1/2 times 12, so that becomes 6. And then what happens to 1/2? We're just going to do the rule. The rule says make the power one less than it was before. Okay, so we do 1/2 minus 1. Okay, but of course to subtract fractions, we need to find a common denominator. So I'm going to write 1 as 2 over 2. So I take 1 over 2 minus 2 over 2. Subtracting fractions, we leave the denominator alone. And we subtract the numerators as long as we have a common denominator. So I get negative 1 on top. So in this case, it becomes t to the negative 1/2, because that's what you get when you take away 1 from 1/2. And then for the last one, okay, again, multiply down this number here, which is going to change my plus actually to a minus. And we have 8, and then t, and what should the new power be? Yeah, minus 2. One less than it was before. Okay? All right, so that's a tricky one. What you need to get used to with these derivative rules is if something isn't in the form where you know how to use a rule on it, okay, you have to maybe rearrange it a little bit, rewrite it, and that sort of thing. Okay? Lena, how we feel about that? All good? All right, any other questions on this one? You got one?
Not this one, boss.
Okay. You got a different one? Or
Yeah, other question.
on which one?
And question 11 on 3.1 block says
Okay, what does it say?
T in years is 2016, the height of sandstone. FT equals 600 minus 4T squared.
Sorry, say that again.
F of T
F of t
yeah,
is
equals 600.
600
Yeah, minus 4 to T squared. Find f of a 5 and f of a prime of 5.
All right. So in this case, to do f of 5, what do we have to do? We just have to take 5 and plug it in for t here. So f of 5 would be equal to 600 minus 4 times 5 quantity squared, which is 600 minus 100, which would be 500. We okay with that part?
Yeah, but why 100?
Why 100?
Yeah, because.
Because 5 squared is 25.
Okay.
And then we multiply 25 times 4 to get 100. All right, and then for the f prime of 5, what we have to do first is figure out what is f prime of x, okay? So to figure out f prime of x, or actually f prime of t, excuse me, what we're going to do is we're going to take the derivative of this guy and write it here, okay? So the 600, what happens to the 600?
0.
Just becomes 0. And then power rule on this becomes minus 8t. And what's the new power? Just 1, which we don't need to write, because anything to the first power is just itself. So to get f prime of 5, all we're going to do is plug in 5, so we get negative 8 times 5, which is negative 40. All right? All set on that one? Any? Yeah?
Do you mind doing like a tangent line equation probably?
Sure. Well, we can just spin off of this one because we already have f of 5 and we already have f prime of 5. So let's find the tangent line to f of x f of t at x equals 5. Okay? Well, we just use the formula. We know that the tangent line, t of x, is going to be equal to f of 5 plus f prime of 5 times x minus 5, yes? So we put in 5 for a in particular in the formula. We put in 5 for a, which in our case, we just replace f of 5 by 500. And then we replace f prime of 5 by negative 40, so I'm going to change it to a minus 40 times x minus 5. Okay, and then I'm done.
That's all you have to do.
Yeah, exactly. So this is an equation of a line, right? It's a number plus a number times x, right? That's what a line is. So we could use this to, say, approximate f of 6. You would plug in 6 here. Oops. You would plug in 6 here, and that would be a good approximation of f of 6.
Why would we not distribute?
You can distribute if you want, but this is the formula. It's up to you. You could also write this in terms of point slope if you wanted to. You could write like y minus 500 equals negative 40 times x minus 5, right? You could write it in point slope form. That's also fine. Or if you want to multiply it all out, by all means. All right. Okay, we got to get to some of our actual class material before we have to do the quiz. So actually, let me set an alarm for that so I don't forget. What time do we do that again?
48 is normally.
Yeah, I think you're right. It's 48. All right, so we got 47 minutes to get through what we have to get through today. But before we do the new rules, I want to go back to the chain rule because I think the chain rule is the hardest rule, and it's the rule that my students struggle with the most, okay? So we're going to start off with just reading the rule, and then we're going to do 2 examples and then move on to the new rules. Okay, so the chain rule for all of our rules, we want to understand when to use it. Okay? So the cue in the problems to use the chain rule is when I see one function inside of another function. Okay? So that could be I have a function inside the power, or it could be I have a function that's getting raised to a power, right? Or it could be that I have like a function inside of the natural log, or something like that. But most of the time, it's fairly easy to identify. Or if I have a function under a square root, right? That's another thing. Okay, so anytime I see a function inside of another function, that's when I want to be using the chain rule. So let's see this one. So let's remember f of g of x, if we take its derivative, is equal to f prime of g of x times g prime of x. Okay? And this one, I'm sorry to say, there's no way to get around memorizing this. So it might be a good idea to write one side of this equal sign on a flashcard and the other side on the other side and practice it so that you get it down. So let's see how it works for this one. So here I can tell that I need to use the chain rule because I see that I have this function ln, and inside the argument of this function is another function. So that makes me think function in a function, I need to use the chain rule. Okay, and the next step is to identify what is the inside function and the outside function. So in our case, the inside function, g of q, is whatever's inside the parentheses in this case, or inside the power in the power case. But it's q squared plus 1 for us today. And what is the outside function, f of z? And we use this letter z, we use a different letter, just so that we don't get confused when we try to plug in this other thing into it later on. Okay, so f of z then is the function such that if I replace all of the z's with q squared plus 1, I get ln of q squared plus 1. So what should f of z be? Yeah, someone said it. ln of z in this case. Okay, so to apply the formula, I need a couple of different things. I need to have f prime, I need to have g, and I need to have g prime. So far, I do have g, but I'm still missing f prime and g prime, because I'm going to need those in order to apply the rule. So I'm going to go ahead and find them preemptively so that I can then go ahead and plug. So next, I'm going to figure out what is g prime. So if g is q squared plus 1, then g prime is going to be 2q by the power rule, and the 1 goes away. And f prime, what is f prime going to be? Can I use the power rule?
1 over z.
Yeah, someone said it. Was that you, Olivia? Olivia got it right. It's 1 over z. We can't use the power rule here. We have a handful of rules. We can only use the rule when the function looks like what that rule is. So the rule that we learned for ln was that its derivative will be 1 over whatever is the argument, which in this case is z.
Why 1?
Why 1?
Yeah.
Okay, well, maybe I can add a page here and explain why 1. So essentially what's happening with the natural log, you can think about it in this way. What does the natural log function look like? It looks like this, yes? And what we're describing is for a given x, okay, if this is ln of x and this is x naught, okay, then what is, so if this is f of x, then what is f prime of x naught? f prime of x naught is the slope of this tangent line. So you could ask yourself, what is going to happen to the slope of this tangent line as x gets larger and larger and larger? Well, the tangent lines look more and more and more flat. You can see this as we move from left to right. You agree with me? So what we see here is that f prime of x is equal to 1 over x, okay? The reason being that as x gets larger and larger and larger, the fraction 1 over x becomes smaller and smaller and smaller, which is to say, as x marches to the right, the slope of the natural log function is becoming more and more flat, okay? So that's sort of a graphical explanation of that. In terms of why it actually, how you would actually derive this from scratch is sort of beyond the scope of this class. It's just something that we learned, okay? I know that's a very unsatisfying answer, but that's what we're going to have to do with the tools that we have. Okay? All right. So that was, where did it go? Oh, so we're not quite done yet, right? We still have to apply the formula, which says I need to plug in the g function into the f prime function. So I'm going to replace 1 over z with 1 over q squared plus 1. And then I'm going to multiply by g prime, which in this case is 2q. So I get 2q over q squared plus 1 as my y prime. Any questions on that one? All right, one more example. Okay, we'll do one more. Okay, we got F, G, and H. Which one looks like the most fun?
H.
H? Okay, we'll do H. Okay, so really quickly, I'm going to show you how I would do this chain rule problem. And how, yeah.
I just have one quick question for the last problem.
Yeah.
If we left it as 1/2 times 2 or q squared plus 1, is that okay, or do we need to simplify it all the way to 1 over q squared plus 1?
Sorry, could you repeat what you said at the first part?
So I have mine just as 1/2 times q squared plus 1 times 2q. Would that not be fully?
1/2 times q squared.
Because f prime is, or oh, it's 1 over.
Yeah,
z.
1 over z.
Okay, never mind.
Yeah, I always put the cross because my z's look like 2's. So yeah, every time I have the cross in the middle, that's a z. Yeah.
My bad.
No, you're good. Okay, so I'm going to show you how I would do this chain rule problem. So after you gain some familiarity with the chain rule, okay, you're probably not going to write out all of this stuff, okay? You're kind of going to go straight from the top to the bottom, okay? And you're going to say, I know this is a chain rule problem. Derivative of the outside function, just put 1 over whatever's inside the parentheses, multiply by the derivative. So I'll show you how I would do this problem in that way, and then I'll show you the long way. So for this one, I don't even really need to use the chain rule for this one because we used the e to the kx rule. The e to the kx rule says that the derivative of e to the 1/2 x is going to be 1/2. We multiply down whatever is the k, and then we leave it alone otherwise. So we get 1/2 e to the 1/2 x. And then I'm going to add, and here's the part where I have to actually use the chain rule. So what I see is basically, I sort of visualize this as a z, okay? This is the z, right? So what I have to do is first the derivative of the outermost function where I leave the inside alone. So I would do 4 times x plus 2 cubed, and then I need to multiply by the derivative of the inside, okay? Which in this case, it's just 1. So I get 1/2 e to the 1/2 x plus 4 times x plus 2 cubed. Okay? So what's really under the hood here, okay, is I'm recognizing that this is f of g of x, where g is x plus 2, f is z to the 4th, f prime is 4z cubed, and g prime is 1. And then I'm doing f prime of g of x times g prime of x. And that's what got written here. But I just sort of skipped this process because after a while you'll start to recognize when you need to use the chain rule, and you probably won't want to write all of that stuff out every single time because it's sort of time consuming. But if you want to, you can always do this method to help you organize your thoughts on the page. Any questions on this one? Alex?
So for the first line, why is the 1/2 x positive?
Uh,
No, like, yeah, the x part.
this part?
Yeah. Why isn't it negative? That's another question.
Why isn't it negative?
Just subtract one.
He thought it was the power rules.
Oh, I see. So, why did we not take away 1 from this? Is that what you're saying? Okay, yes. So that's because the power rule, okay, it works for stuff like x to a number, okay? Which there's a big difference between x to a number and a number to x, okay? So the way we do these derivatives is completely different. This one would become 3x to the 2, right? Make the power 1 less. But if x itself is in the power and the base is a number, then we have to use one of 2 rules. The 2 rules we learned to deal with that were that the derivative of e to the kx is k times e to the kx. And the other rule we learned was the derivative of a to the x, where a is a number, not e, is equal to, or it could be e as well, is equal to a to the x times ln of a. Okay, those were the 2 rules that we learned for those 2 derivatives. So because this e to the 1/2 x, we can't use the power rule because it doesn't have the form x to a number. It has the form number to x, which is not the same thing. So that's why we can't use the power rule there. That's a great question, though. Was there another question, Drew?
I don't know. That answer.
Cleared up? Okay. Anyone else have questions on this one? Yeah. Okay. Then if no questions, we're going to move on from chain rule and talk about the last 2 rules.
Next week, what quiz do we have?
Next week will be quiz 7, right?
Yeah.
Which will be on 3.3 and 3.4, and then I don't know if there will be another homework. We probably won't have another homework in time. So yeah, 3.3 and 3.4 for next week's quiz.
I asked because you didn't write it.
Sorry?
I asked because you didn't write it.
Yeah. Okay, so quiz 7 next Thursday, 3.3, 3.4. Yeah.
Sorry. When's our final? Or, yeah, not our final, our second exam.
Second exam, I think it's April 11th. Can anyone confirm that? Check your calendar. Does nobody have it written in their calendar? Oh my god.
Calendar's not.
It is April 11th? Okay, good. All right, April 11th. So, yeah, a little less than a month away. Plenty. Plenty. Yeah, so, I mean, we'll probably make it through chapter 4 by the time we have the second exam, and then we'll have Basically, the second exam will be over derivatives and their applications, and then the last exam, or the final exam, sorry, will be over. Well, it'll be comprehensive, but it will lean somewhat towards the integration that we do at the end of the semester. Sorry?
It's not on everything that we study.
It is. It's cumulative. Yeah. But there will be a bias towards recency.
We could be like a lot of like the first test on it.
Sorry?
There'd be a lot of like the first test on it.
No, probably not.
Please.
Man, you guys are really putting me through the ringer today. Okay, let's do the product rule and the quotient rule. And I'll think about how much we're gonna put quiz or exam 1 on the final, okay? All right, so product rule and quotient rule are two new rules which are gonna help us to do derivatives of the following type. So we've seen how to do the derivative of a composition. So chain rule was for stuff like f of g of x, where one function is inside of another function. For product rule, okay, it's for when we are doing the derivative of one function times another function. Okay, so you can see an example of that here. We have the function x squared being multiplied by the function e to the 2x. So that's the sort of thing that we would need to use the product rule for. And based on what we've learned so far, okay, you might be led to believe that this is going to just be, well, the derivative of a product, maybe you would guess, is going to be the derivative of the functions multiplied together. That would be the thing that makes the most sense, but it turns out that's actually not true, okay? And we have to use a different rule instead, which says that the derivative of a product will be equal to the derivative of the first function times the second, and then plus the first function times the derivative of the second function. Okay? And I guess I'll also write the sum difference rule, which is what might lead you to believe this. Okay, what we learned before was that if you have f of x plus g of x, the sum, then the derivative of a sum is the sum of the derivatives. Okay? However, the derivative of a product is not the product of the derivatives. It is instead given by this formula here. Okay? This formula here. So again, this is one of the ones that you're just going to have to memorize. Put one side on a flashcard, put the other side on the other side of the flashcard. Okay, and that's one that you'll need to memorize. And you'll also need to be able to, again, see the cues for when I need to use the product rule. We have the cue for when we need to use the chain rule. What's the cue for when we need to use the chain rule? Yeah, Ashlyn and Andon both said it. It's when there's a function inside of another function, okay? That's when I want to use the chain rule. When I want to use the product rule is when I see one function being multiplied by another function, okay? A product of functions. All right, so that's the product rule. Let's see it in action. So for this first one, we have two functions being multiplied together, okay? And I like to sometimes separate them out so that you can see exactly what functions they are, okay? In this case, we have x squared being multiplied by e to the 2x. And if I want to do its derivative, okay, then what I need to do is, the first thing I need to do is the derivative of x squared, and I'm going to leave e to the 2x completely on its own. So this will be 2x times, and e to the 2x just stays what it is, okay? We don't do its derivative. But then we have a plus, and we're going to switch the roles, okay? This time we're going to leave x squared alone. And we're going to multiply times the derivative of e to the 2x, which would be 2e to the 2x. Okay, so the derivatives which we did here were this one here, okay? And then the other one here. So these were the derivatives. So it's derivative of one and not the other, and then it's derivative of the other and not the one. Okay? So that's a product rule example. Let me do another product rule example. Here we have t cubed times ln of t plus 1. Identify the first function here as t cubed and the second function as ln of t plus 1. And I know my job with the product rule tells me to do the derivative of t cubed first and leave ln of t plus 1 on its own. And then what comes next?
ln of t plus 1.
Not quite.
Oh.
We got to keep, so the first thing we did was we did the derivative of t cubed and left ln alone. Then I have to do plus, and I have to do what? I have to swap the roles, right? So now comes t cubed, and we multiply that times what? Now I got to do the derivative of ln of t plus 1. How do I do that?
Chain rule?
Sorry?
Chain rule?
Yeah, chain rule. Although it's sort of a trivial chain rule because of the following. You would do 1 over t plus 1, and then what would you multiply by?
1.
You'd multiply by the derivative of t plus 1, which is just 1. Okay, so it actually just goes away. So it would be t cubed times 1 over t plus 1. Okay, so this is how we split this up. So this is like our f, this is like our g, and this is f prime g plus f g prime. Okay, this is f prime g, and this is f g prime.
Well, you didn't switch it.
Switch what? You mean left and right?
Yeah.
The reason I don't switch left and right is because 3 times 5 is the same as 5 times 3, right? So you can write multiplication in any order that you want. But what I mean when I say switching is I'm switching the roles. The first thing I do is I let this one, we do its derivative, and then we leave this one alone. When we switch roles, then I'm going to leave t cubed alone, but do the derivative of ln of t plus 1. That's what I mean by switch roles. Does that clear things up? Okay. Yeah.
Do you have to use the chain rule for the ln one, or do you just do the
You can just okay. Technically, it is the ln rule, okay? But if we had anything fancier inside, like say there was a square here, then we'd also have to multiply times like 2t, right? Something like that would be what we would get. You see what I mean? So it's chain rule in the sense that there is a function inside of a function. So yes, technically you should multiply by 1 here, but it's sort of, you don't have to write it. So whether you don't write it because you consciously chose not to, or whether you don't write it because you maybe forgot, or you had a misunderstanding, there's no way for me to know which one it was. Does that make sense at all, if I say it like that?
So I should usually use the chain rule?
You should use the chain rule every time that you see a function inside of another function. And then that way you'll never forget to do it when you need to. In this case, it turns out that you didn't need to, but if you do it, you'll end up just multiplying by 1, which is not going to harm you, right? Okay. So that's part B. All right, how do we feel about the product rule? Raise your hand if you think product rule is easier than chain rule. Almost everyone. Okay. All right, I would agree with that. So let's see another rule, quotient rule. Quotient rule is not that hard, but it is annoying, okay? It's about as hard as product rule, but it is more difficult to memorize, okay? And there's a couple of small pitfalls. So what is the quotient rule? The quotient rule is for when I want to do the derivative of one function being divided by another function. And the results will be the following. F prime of x times g of x minus f of x times g prime of x, all divided by g of x squared. Okay, so the reason I say this is annoying is because this is kind of complicated to memorize. So there's a couple mnemonic devices that people use for it. The one that I hear most often is the following. It says low d high minus high d low over low squared. Low squared is what I hear people say. Okay, so what they mean by that is that we call this one low and we call this one high, and this is like low and this is d high, and then this is high and this is d low, and then this is low squared. Okay, that's how they say it. So if you want to memorize that mnemonic device, you can, or if you have another way of memorizing it, then by all means do so. Does anyone know any other mnemonic devices for this? Ways to remember the quotient rule if you've taken a calculus course before? No? Okay. That's the one. Okay, yeah. So that's what I hear most often. The way I remember it is actually the following. I remember the product rule, and what I do is I just switch the plus to a minus, and then I divide by the denominator. Okay, I switch the plus to a minus and divide by the denominator. Okay, so here's one pitfall that you can fall into with the quotient rule. For the product rule, if I mess up the order, everything's going to be fine. Okay, because if I accidentally do g prime f plus f prime g instead, well, that's okay because addition can be done in any order, right? 3 plus 5 is the same as 5 plus 3, so we're happy, right? If we switch the order in the product rule, no big deal. If we accidentally switch the order in the quotient rule, it is a big deal because 5 minus 3 is not the same thing as 3 minus 5, okay? So we'll actually be off by a factor of -1 if we switch this up. So you have to remember what is the first term in the numerator of the quotient rule, so that then you can say, then I'm going to subtract and switch the roles, okay? But if you accidentally do g prime f minus f prime g, okay, then you're going to be in trouble. Okay, if you switch the order, you will be in trouble. So, are there any questions on the rule before we see some examples? All right. Let's see examples then. All right, here we go. So this one, we have, I'm going to change this to be an h, and I'm going to let this be the f of t in the numerator over g of t in the denominator, where f is e to the 2t, g is t, and I know I'm going to need their derivatives, so I might as well do them now. F prime is going to be 2e to the 2t, and g prime is going to be what? Yeah, 1. You can see that in two ways. First of all, this is a linear function. The derivative of a linear function is the slope of that function, which the slope of the function, which is the identity function, is just 1. The second way is you can think of it as t to the 1, where you take the 1 down and you take away 1, and you would get 1 times t to the 0, which would be 1 times 1, which would be 1. That's the other way you can see it. All right, so g prime is just 1. So now we're going to do the following. We are going to do f prime g minus f g prime all over g squared. So this is the part where you just have to have it memorized so that you can write it down. And now we're going to fill in the blanks, okay, with all of this stuff. So we get 2e to the 2t times t minus e to the 2t times 1 all divided by t squared. Okay, all divided by t squared. So I know I did that quickly, so let me go back and show you where all this came from. So first of all, identifying what is the top and what is the bottom. And then I identified what is the derivative of the top, what is the derivative of the bottom. Okay, and then I did low d high minus high d low over low squared. Okay, where low is g and high is f. High over low. Okay, so once I had those, I just plugged each one of them into their respective spot, and that's what we get. All right, any questions on this example? Okay, I know this chapter has been really boring with a lot of me talking and doing examples on the board and not much of you guys working together. I promise in chapter 4 there will be a lot more interaction and group work, and get your hands on this stuff yourself. It's just that when we're learning so many different rules, I have to just kind of spit them all out and give you a couple examples. So make sure that you're using the homework as a tool to help you learn, okay? All right, let's see one more. So we've got p equals 5q squared over q cubed plus 1. Okay, so this is f over g. So I have to remember what the quotient rule says. So let's say that I don't remember the formula exactly, but I can remember that saying. What was that saying again? It was low d high minus high d low all over low squared, right? Okay, so let's call the top high because it's on top and the bottom low. Okay, so our high is 5q squared and our low is q cubed plus 1. Now to figure out what d high is, I need to do the derivative of the top, which is done using the power rule. It becomes 10q. And d low is the bottom, which becomes 3q squared. And the 1 just goes away because the derivative of a constant is 0. So if you want, you could put a plus 0 here, but it's kind of pointless because adding 0 doesn't do anything. All right, so now I've got my high, low, my d high, my d low. I'm just going to plug them into the formula. So low is q cubed plus 1. I put it in parentheses because we always plug with parentheses. And then d high will be times 10q. Then minus, now we have to have high d low, right? High d low. So that's 5q squared times d low, which is 3q squared. And we divide all of this by low squared. So low is q cubed plus 1. And we write it down in parentheses and we square it. So this is p prime. Do we like it better when we write with low d high, high d low, all of that stuff, instead of the f prime g stuff? Does anyone have an opinion? Who likes low d high better? Who likes the other one better? Okay, we're gonna keep with the other one then. See, you did have opinions after all, you just didn't want to say. Am I that intimidating? I feel like I'm a friendly guy. All right. Maybe it's just too much of me talking and not enough of you doing things. So let's have a you doing things part. Okay. We already did a graph one, so let's do problem number 2 this time. Okay, so we're going to work in groups on problem number 2. And again, they give us a table, but not the actual functions themselves. So we're going to have to remember, okay, we're going to have to remember how to do the quotient rule and the product rule, and how to read information from a table in terms of the values of the derivative and the function itself, okay? So I want you to focus on A and D, and if you finish those, okay, then you can go and work on C and B, okay? So work on A and D first, and I'll be coming around with Jacob to help you if you need a little help.
So, if h of x is f of x times g of x, then what is h prime of x? Prime of x. 2, 4 times so that's all plus f of x times g prime. Right? So let's write that down. So h prime of x.
X is equal to t minus c of values. Writing that function, so just put it values. Not too dumb.
Hang on. So, if I want to do h prime of 2, what do I need to do? I need to put a 2 everywhere I see an x. Okay, well, first of all, this should be plus. Oh, now you see what's going on? Okay.
Yeah.
Okay, so this is 4 is coming from f prime of 2, and 3 is coming from g. And then we have
Yeah, it's a really weird feeling, isn't it?
It is a weird feeling. I'm not used to it.
Yeah, this looks good, right? Because we use the product rule, because it's replacing h prime of x by f prime of x times g of x plus f of x times h prime of x. And when we to do 2, we just plug in 2 everywhere, and we get all these numbers in the table.
I'm so tired, bro.
It should be plus for product rule, it's plus. That's quotient rule, right? But for this one, we're multiplying together. So we're multiplying together, we use product rule, which is f of x.
It's like the business. It's like the cost, marginal cost and stuff. But I don't really remember how it like relates to like the derivative.
I guess we
I can do the derivative in marginal cost.
You'll obviously like the final f prime of x. I think I'm also over that a lot, like, right, but it's a lot easier than what we do, we just replace all of the active types, and you get all of the intermediates with most of it. So yeah, when you raise the tree, it's repeated. Okay,
It's like it's interfering with what should have been done every time. All my roommates were saying like, you know, the most too comfortable about it.
Well, the thing is, yesterday I took one out of 3 classes.
so what do we have? Today, HVAC times speed, right? But the question that we're asking here,
But yesterday was
so the question that we're asking here is not what is each so HVAC is given by this. So we got to figure out what each HVAC has to do with each time function. That comes from the product program, which I guess is on the case for this.
I didn't have like other
Similar to this, which says we're gonna get F prime of X.
I really only had this one, so this is less reason I don't come over this way, because normally my other
So
classes.
if I want to know what's E prime of 2,
Oh, that's nice.
what I need to do is
So I literally just
here,
fall down this,
which means we're gonna replace all the X's here by 2, right? And if I want to figure out what is F prime of 2, see how I can get it from the table.
I don't know, whatever, I'm just
On the
gonna
top
like order some
row, you
Starbucks.
can see what X is, go to the column where X is equal to 2. We go down to the row where we see F prime.
I only have like
That
20
gives you the so that's what we get for F prime of 2, and then for G is what we
These will be on
do the same thing,
Starbucks,
go down to G.
swipes.
Does that help?
That's actually wild. I can't even say it right now. Like I said, I have like 5.
Sorry, I'll do it in front.
I should drink some coffee. It's just like
That's a lot of
my friend though, says he's like, he's doing wrestling now. For his tournament coming up, he's like, okay, that's good. He's like, I can't like use my $10 or anything. Like just nasty and all order. So I'm like those $8 bougie ass drinks. He's like, I got you.
Yeah, exactly. He's kind of tricky, right? But we have two functions being multiplied together. What's not important is, you know, what is the letters themselves, but the fact that we have one function times another function, which the whole deal with the product rule is whatever you call those functions, you need to do the derivative of one, not the other, and then add to the derivative of the other, not the one, right? So for this one, we're going to do f prime of x times f of x plus f of x times f prime of x. That make sense?
Mom also like just got delivered like 2 minutes ago a new thing of protein. I got her review, so like I know, but I just I was thinking about like going to play basketball, but it's just like dying.
So we got h of x, right, is given by the product of these two functions. Write down h of x here, h of x times b of x.
I got so much money. If I could like find somebody to drag along with me, maybe I'll go. Like,
My friends are together.
That.
I forgot this stuff.
Now this says,
Yeah, I wanted to Planet Fitness membership because it's like, well, also like I can like,
so once we get
tan,
that,
I get no.
we can drive it derivative in the following, right?
But
H prime of x,
yeah,
f prime of x times
if I get all my work done before I gotta take my friend.
plus f of x times g prime of x, right?
Either that or
So for the problem, what they ask us to do is h of 2, right? So what are we gonna do? We're gonna put a 2 here, 2 here, 2 here.
Dude, trust me. Trust me.
And then from there,
It is.
that's how
It is.
table that
I finished all my homework last night and took one and like just sat there and I watched that Hangover and
I love
that color coded and everything.
I just sat there and watched it. I was dying laughing.
How are you two doing?
I think good.
You get to the last two as well?
I don't, I haven't done C because I was scared of C.
You're scared of C?
Yeah,
Why?
because there ain't no F of X.
That's true, there's just a g of x. But what is the derivative of a constant times a function? What's going to happen with this 3 here? No.
No, he stays.
It stays. It's just going to stay, and its derivative will just be 3 times whatever is the derivative of g.
Oh, okay. I thought we knew that.
Yeah, no reason to be
We need to
scared.
go out of the way and get like an F of X here.
No, but you could use the product rule if you really wanted to. You could just say, this is 2 functions. This is the function 3 times the function g. But the thing is, when you end up doing the derivative of the function 3, it'd be 0, which would go away. So it's sort of redundant. We're not, it's suboptimal to use the product rule for that one. All right, let's quickly discuss the solutions here. So what do we have? We have f of x times g of x. So this one's just a straight copy of the rule. H prime of x is going to be f prime of x times g of x plus f of x times g prime of x. Okay, so I'm just going to put in a 2 for all of the x's. 2, 2, 2, 2, 2, and read these values from the table. So for f prime of 2, I'm going to go to where x is 2, and then I'm going to go to the row that corresponds to the values of f prime, and I'm going to see where they cross. That gives me 4. So that's how I get a 4. And then g of 2 is 3. And then f of 2, f of 2 is just 3. And then times g prime of 2, which is also 3. Okay? So just multiply those out and add. Okay, for the quotient rule, it's the same thing. We're just going to, rip this straight from the rule. So it's g of x, h prime of x will be equal to g of x times f prime of x. That's low d high. Minus, and now we do it the other way. F of x times g prime of x. That's high d low. All over low squared. So again, I'm just going to replace all of these guys. I'm going to replace the x by 2, and then I'm going to find all of the corresponding values from the table and multiply them out. I want to spend just a minute talking about part B and C here, okay? Where part B, the point of part B is to say that, look, the letters of what we're doing here don't matter. What matters is the form. Here we have a function times a function. It's a product of functions. The way you take the derivative of a product is first by doing the derivative of the first function and leaving the second function alone, and then adding and switching the roles. So leave the first function alone, multiply times the derivative of the second function. In this function, in this example, you end up getting 2 f of x times f prime of x, which is not that surprising given that there's another way we could write this expression as the function f of x squared. And then we could do its derivative using the chain rule, which would give us 2 times, leave f of x alone, multiply times the derivative of the inside, which is exactly what we got when we did the product rule as well. So there's a lot of times where the rule which you can use is sort of up to your discretion, which is also demonstrated in part C, because part C, yes, is a product, but it's a product of a number with a function. So you could go ahead and use the product rule where you would get 0 times g of x plus 3 times g prime of x. But when you do this first part, you see 0 times anything is 0, so it goes away. So it turns out the derivative of 3 times g prime of x is just 3 times the derivative of g prime of x. But we already knew that from the constant multiple rule. The constant multiple rule says if you're doing the derivative of a constant times a function, the constant is just going to hang out, and we're going to do the derivative of that function. Okay? All right, so some of these are sort of, you're primed from the lesson to think, I got to use product rule and I got to use quotient rule. You don't necessarily have to on some of these. Okay, any questions? All right, then let's clear our desks for the quiz.